Today we'll cover an early-day LeetCode medium question. Add two numbers. In the question, you are given two linked lists of nodes with digits stored in each node in a reverse order. Your goal is to return a similar linked list of nodes as the summation result. It is known that each digit is a single digit between 0 and 9, and there are at most 100 nodes in each linked list. It is also guaranteed that the represented number in each list does not have leading zeros. The trick to solve this question elegantly is similar to the one used in big number addition, in which the numbers are stored as strings or list of characters. You need to iteratively perform the summation on not only the digit values, but also the carrier from previous calculation. And let me demonstrate it. First, let me call this digit array or linked list addition. And assuming that we have two arrays or linked list here, one with 2 values and the other one with 3 values. We'll usually default a carrier to 0 here. We'll do a summation for first digit. Remember that all the digits here are already sorted in the reverse order so that we can iterate both arrays from left to right. Once we do a summation, we'll do a modulo here and keep the remainder here. The carrier will be moved to the next digit, and then we'll do again the summation here. We'll keep the remainder here. I'll do this again, move it to here, and then do a summation here. Remember here. And in case there's still a carrier left, we'll redo the same process. Eventually, this is just a carrier by itself, and we'll put it here. So that's basically the strategy we're going to use. We'll basically monitor not only the carrier, but also all the values in both lists, and do a summation. We'll only stop if both lists have been viewed and the carrier is now 0. Now let's take a look at the pseudocode. If we have a function here, as I said, I'll default the carrier to 0. So if the first linked list is not none, or the second linked list is not none, or the carrier is not 0, I'll keep doing the following steps. I will increment the carrier by the node value if this node is not none. We'll do the same thing for a second list. And after that, I will get a remainder, which is literally just the carrier modulo 10. And then we'll have a new carrier, which is divided by 10. We'll then just keep these remainder values in the array or a linked list. And this is basically the pseudocode. Now let's move on to the code implementation. What I'm going to do here in the implementation is very similar to the steps I mentioned in the pseudocode, except for the fact that I actually need to keep the results in a new linked list. I will first create a list node called head, and also root assigned by a dummy linked list node, which is default to -1. I also need to initialize the carrier to 0. Now I'll start iterating through both lists. While L1 is not none, or L2 is not none, or carrier is not 0, I'll keep doing the following steps. Carrier will plus equals to L1.value if L1 is not none, otherwise it will be 0. The same thing for the second linked list, L2.value if L2 else 0. After I have the carrier value, I will need to calculate the remainder and keep it in the new node. Add.next will be equal to list node carrier mode by 10. Afterwards, I will update these carrier values by divided by 10. After I finish dealing with this current digit, I will need to move all the heads forward. It means that L1 will be assigned as L1.next if L1. Otherwise, I'll keep it as none. Same thing for L2. At the end, I also need to move the head forward. This for loop will keep going on for a while until the point that L1 is none, L2 is none, and carrier is 0. At that point, I can just return the root.next. Root is the anchor of the dummy node, so root.next is exactly the length size we want to return. And now let's try if it works. Awesome, passed 3 cases. Now let's do summation. You can see performance is around in the middle, it is around 60% of the users. And that's the end of this video. Thank you for watching.